Hello everyone. In this video, I'm going to explain friction on a slope or friction on inclined plane. Previous lesson was about the friction on a horizontal. When a friction is applied on a horizontal, we have an object and the gravity is acting on the center of the object. So this weight, it makes a 90 degrees, which is perpendicular to the plane, because from center to gravity, it will be 90 degrees and straight down. Now, a normal force is equal to and opposite this, so it is also perpendicular to the plane. Now, if we take the same object and place it on an incline, this is the slope, so this is the horizontal, this is the plane. So this plane makes an angle with the horizontal. The weight now from the center of the object straight down to where gravity is. This weight is no longer making a 90 degrees. So if it does not make 90 degrees, you resolve it into horizontal and the vertical component. It's no longer making 90 degrees. So the weight must be, or the normal force must be perpendicular to the plane. Now let's have a look at this diagram. I want to sketch it here. I'll explain using this. The weight from the center of the object down, so this is W equal to mg. In some questions, you can be given the weight in newtons, but in some questions can be given the mass of the object in kilograms. Now, since this weight is not perpendicular to the plane, this angle here will be equal to, when we resolve it into horizontal and vertical component. So these are the two components that replace this weight and produce the same effect. This one is perpendicular and this one is parallel to the plane. If we complete a parallelogram, these components will be like this, or a parallelogram would be something like this. This component is this one, and this component is this one. Parallelogram, two opposite sides are equal. The direction of this one is downwards. Also, this side, it will be downwards. The direction of this one is to the left. Also, this side, it will be to the left. This angle is equal to the angle formed between this component and the weight. Now, since this component makes 90 degrees with the plane, it is called the gravitational, because gravity is acting on the object. These two components are called the gravitational components. So this one that makes 90 degrees is called the gravitational component that is parallel to the plane. And to get what is represented by it, we use the soccer tower. This is a right angle triangle, so this will be adjacent over hypotenuse, and this will be cos. So this component is the one that is called FC, and it is equal to W cos of theta, because it uses cos. When you are not given W, where there is W, it will be mg. So the same component is mg cos of theta, which is the same as this one. This component is opposite over hypotenuse. Opposite over hypotenuse is sine. So the same component, or the one that takes sine, will be Fs since it takes sine. So it will be equal to W sine of theta. Or where there is W, you can put mg sine of theta. This G must be in kilograms. If it's given in tons or any other units, you always convert to, given in tons, given in grams, you always change it to kilograms. Can also be in megagrams. Now, to sketch this, we need two components that are attached on the block. So the diagram that you will do for your calculations, it will be the object and the weight is acting, W equal to mg. It will have this component is attached on the block. So it's Fc, which is equal to W cos of theta. Another component that is attached, two components, we're going to focus on this one and this one. So the second component will be Fs, which is mg sine of theta or W sine of theta. Now, if there is no external force applied, when there is no external force applied, this object can possibly move down the slope because gravity will be acting on the object. Now, friction opposes the motion. Friction will be acting the opposite way. And the normal force, you extend the gravitational component that is perpendicular to the plane, and it will be NR. Theta is the angle there, angle of slope. This is the gravitational component. This one is parallel, so it's gravitational component parallel. This one makes 90 degrees with the plane, so it's a gravitational component perpendicular to the plane. Even if the object is placed on a slope, the normal force is reacting to Fc. Weight is replaced by two components. So this is reacting to this, and this is reacting to mg sine. So these two forces are reacting. Even if the object is placed on an incline, the total reaction force Tr is the sum of what is reacting, and is given as the same formula as on the horizontal plane. So when we add x and y, use Pythagoras theorem, so it will be frictional force squared plus normal force squared. Angle of friction is still between normal force and the total reaction force. So when we calculate it, it's still the same formula as of the horizontal. It will be tan theta equal to opposite over adjacent, which is the normal force. Then where there is friction, if you put mu multiplied by nr, because friction is mu times normal force, and you divide by nr, cancels out. So even at this chapter or in this topic, we still have two formulas to calculate the angle of friction. There are two formulas. Now let's consider this diagram. If we assume that this slope is maximum, or the friction is maximum, these two will be equal because static friction is the maximum friction. Also, this will be equal to this one. So for a maximum friction, we apply equilibrium equation. Equilibrium condition on the upwards is sum of the upwards forces must be equal to the sum of the downwards forces. So if you look at this diagram, the normal force is upward. So NR is upward. It is the only force that is upward because total reaction is the sum of the two. So normal force is the only force that is upward. But this one is the only force that is downward, which is W cos of theta. That's why you see your textbook saying that normal force is equal to mg cos of theta, because these are the only two vertical forces, and this is balanced, they are equal. Now, if we consider the equation for the forces that are parallel to the slope or to the plane, we apply the equilibrium condition that forces that are to the left, if this thing is balanced, they are equal to forces that are to the right. You look at this diagram, a force that is to the left is W sine of theta, or is mg sine of theta. And a force that is to the right will be frictional force. So a frictional force is given by mu multiplied by normal force. So if we can substitute where there is friction, we put this mu times normal force. This W sine, that means we are putting these two equations together. This is equation 1, and this is equation 2. Equation of the vertical and equation of the horizontal. So this W sine of theta will be equal to coefficient of friction multiplied by the value of R, which is normal reaction. W sine of theta will be equal to mu multiplied by the value of our normal reaction is mg cos, or normal reaction is W cos. So we're going to put W cos here. And we divide both sides by W cos of theta by W cos of theta. Cancel out the mu equal to W cancels W. Sine over cos in maths is given as tan of theta. Remember, this theta is the angle of slope, but this phi here is the angle of friction. So if you are given mu of 0,4, it means these two angles will be equal. Because when you substitute mu here and you substitute mu here, you're going to get the same angle. So the angle, this one of slope, will be equal to the angle of friction. So this angle of slope, the theta, is called the angle of rest or angle of repose. It's called angle of rest or angle of repose. When you define it, it is the greatest angle of slope that can be reached before an object can slide down on its own. At that point, it means that the friction is maximum. So these two angles, theta will be equal to phi at maximum slope. Or when the friction is maximum. The two angles will be the same. Now let's look at the information regarding the inclined plane. W stands for the weight of the object is vertically straight down. Fs is W sine, the component that is parallel to the plane is gravitational component that is parallel to the plane, or parallel component of the gravitational force. Fc is W cos, is the component, gravitational component that is perpendicular to the plane. Theta, that angle of slope. Sorry, this is the first one, the angle of friction, the angle between the total reaction and the normal reaction force. So it is the one that is between the total reaction and the normal reaction. Another, this is phi and this is theta. Theta is the angle of rest or angle of repose. When we define it, it is the greatest angle of slope that can be reached before an object starts rolling down on the plane without being pushed. But angle of friction, you define it just using where it is located, is angle formed between total reaction and the normal force. These formulas do not change. Frictional force is mu r, total reaction, Pythagoras, and to calculate the angle of friction or angle of rest when the slope is maximum, this will be the same formula. You can use theta for both, you won't be penalized. To calculate the unknown, we use the equilibrium condition. Sum of perpendicular components of vertical upwards is equal to vertical downwards to get the value of normal force. Also, we apply it on the horizontal direction, that left must be equal to the right, or sum must be 0. Now let's look at the activity. This is taken from the question paper of November 2018. Yeah. I'll do 6.2. An object with a mass of 40 kg is pulled down and inclined with an angle of 30 to the horizontal. The coefficient of friction between the object and the incline is 0,3. Calculate the following. So in order to get this correct, you need to sketch the diagram. Always do the sketch so that whatever you answer, you don't memorize, you just look at the diagram. It is easier when you understand the diagram. So M is 40 kg, N is 30, mu is 0.3. Let's look at the solution. M is 40 kg, angle is 30, coefficient is 0.3. So if it's placed on an incline, you sketch and you show all the forces that are acting. Weight is acting vertical straight down, which is W equal to mg. Component, you resolve it into FC, and this one will be Fs. The normal force is there, and the friction will oppose the motion. It always opposes the motion. Now, first question says calculate the weight component parallel to the plane. Weight component parallel to the plane. So the component of a weight that is parallel to the plane, this is the weight, it has two components. This is the plane, this is the component. So Fs is parallel. To answer number one, Fs is equal to mg sine of theta. It's the one that takes sine. That's why it is labeled as Fs. So where there is m is 40 times 9.8 sine of theta. Then you use your calculator to get the answer. It's 40 times 9.8 sine of 30. The answer is 196. 196 newtons. That is the answer for the first question. Second question says, calculate the weight component perpendicular to the plane. This is the plane. Perpendicular makes 90 degrees. So this is the component that is perpendicular to the plane. Number two is Fc equal to mg cos of theta. Remember, it's Fc because it uses cos. This one is Fs because it uses sine. So m is 40 multiplied by 9.8 cos of theta. You use your calculator to get the answer. It's 40 multiplied by 9.8 cos of theta. This is 339,482, 3 decimals after the comma unless stated otherwise. 339,482, that is the weight component that is perpendicular to the plane. Number three, to calculate the frictional force. The formula for a frictional force would be given. Frictional force would be equal to mu multiplied by nr. So the value of mu is 0.3. Value of normal force will be equal to this one. If you do the equilibrium equation, sum of the upwards will be equal to the sum of the downwards. Normal force is upward, but what is downward? Remember, the weight is replaced by two components. So what is downward is Fc. Normal force is equal to Fc. And this is the answer for Fc. It will be multiplied by 339,482. Then you use your calculator to get the answer 0.3. This is 101,845 newtons. That is the frictional force. Last question says calculate the force that is required, external force that is required to pull the object up the plane. What is the external force that is required to pull the object up the plane? So to answer 1, 2, 3, there was no external force involved, but the last question involves the external force. You go to your diagram, you add that force up. This is down the slope, this is up the slope. So that external force, where there is friction now, will be Ft. And the friction will never be in the same direction as the applied force. The friction will change to opposite direction. It opposes the motion. Now you write the equation for the horizontal because the unknown is on the horizontal. Forces that are to the left must be equal to the forces that are to the right. What is to the left? 1, 2, sum of the forces to the left. So frictional force plus Fs are both to the left-hand side. but Ft is to the right. Then you got that the answer to this question is to add friction and Fs. So friction is 101,845 plus 196, which is the value of Fs. You use your calculator, plus 196. This is 226,553 newtons. This is the answer of Ft. In some questions, you can be asked to calculate the smallest force that is required to pull it down the plane. Let's say this was the last question of this example or of this question paper. So when you calculate the force that is required to pull it down, you go to your diagram, or let me sketch a new diagram. This will be FSC, this will be Fs. This is normal force. Question says force that is required to pull it down the plane. So you go to your diagram, you add that force Ft down the plane, which is applied force. Friction opposes the motion. It will be the opposite direction of it. You apply equilibrium condition or equation, forces to the left must be equal to the forces that are to the right. So you look at this diagram according to the new question. Forces that are to the left, it is Ft plus Fs equal to what is to the right. This is to the left, both to the left. But friction is to the right, the frictional force. So you make Ft the subject because you're looking for that smallest force. Ft will be equal to frictional force minus Fs. You substitute. Frictional force is 101,845 minus 196. So gonna get negative answer here. 101,845 minus 196. The answer is negative 94,155 newtons. So the negative answer shows that this object can slide on its own. We didn't need a force to pull it down. Thank you.